All right, so the 4 covered the first of the shortcuts that we're going to learn to proving that two triangles are congruent, which is side, side, side. So this question says the vertices of GHI and RST are there given to you, and you're trying to determine if GHI is congruent to RST. So all I did was plot them first, and then obviously you need to find the length of each side. So the ones that are horizontal, you would obviously, easiest thing to do is just count it. This is going to be a length of 4. This is going to be a length of 3. And then the same thing over here, 4 and 3. Before I even went to find that last side, I would make sure those two match. Because if those two don't match, then I can save myself the trouble of going to the last one. But then I've got this ST, which I've got to use the distance formula to find. And then I'm going to find the distance formula for HI and make sure that they match. So ST, I'm using those 2 points, which is -9 minus a -5 squared plus 5 minus 8 squared. And then HI, I'm going to use those 2 points, which would be the square root of -2 minus 2 squared plus 2 minus 5 squared. I get the square root of -4. Yep.
Can't you just check the rise over the rim?
No, that's just slope. That's not distance. So it will tell you the slope of that line, but it's not going to tell you the length of it. In order to prove side, 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 you've got to know that the lengths are the same. So 16, because slope can be longer but reduced, right? Does that make sense?
Yes.
Yeah, okay. 16, 9, square root 25, which is 5. And then this one, -4 squared plus -3 squared. Again, 16 plus 9, square root 25, which is 5. So the answer to are they congruent is yes. And if it had asked why, it would be because of side, side, side. The lengths of all 3 sides match. Yep.
Would you have to do the distance formula? Because wouldn't you already know that that line's going to be the same length in both of them because they're the same? Because the other 2 sides are the same.
No, because you can have an angle that's not 90. It's only like that because it's a 90-degree angle,
Oh.
right? But you can have something that's not a 90-degree angle. If those are spread further apart, now your other side's not going to be the same.
Okay.
Does that make sense?
Yeah.
Yeah, okay. And then number 2 says, is triangle ABC congruent to XYZ, and explain. So again, we only know one shortcut, which is side, side, side. Do I have a match to side 6?
Mm-hmm.
Yes. Do I have a match to side 4?
Mm-hmm.
Yes. And then the other one, I only am given that this is 5 and this is 5. But what's true about the little segment that is left off of both of those sides?
It'll be the same.
It would be the same. What property would I use to describe that? If I was to show that that equaled itself?
Reflexive.
Reflexive, but I do have to use segment addition to show that that whole length is equal to it, which is in one of the proofs, which we'll do in a minute, okay? But the answer here is yes. No matter what value I gave CX, I'm adding it to both of those sides, and since 5 plus whatever that value is and 5 plus whatever that value is going to be the same, it would be side, 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 okay? So the missing side length or measure is shared, okay? And if I use that in a proof, it's because it's reflexive, because you're adding that same segment onto both sides. Camilla? You would use both. So you would, if you wanted to do this in a proof, you would have to say that AC equals AX plus XC and ZX equals ZC plus CX, and that's the segment addition postulate. Then you would say AX equals CZ, that's given, and XC equals XC. Actually, this is not given, this is the definition. This would be substitution. Because given would be that AX equals 5 and CZ equals 5. This is substitution, and then this is reflexive. And then AX plus XC equals CZ plus XC. That's the addition property of equality. And then because we say that these are that, I can say that AC equals ZX. That's substitution again. That would have been my third side, which would have then led to the triangles side, side, side. But again, it just said to explain. You didn't need to go into that detail. That is on a proof, which we're going to do in a minute. All right, so 24 said you were given GH is equal to JK, HJ is equal to KG, and you're trying to prove that those two triangles are congruent. So the first part's given, okay? And if you think, again, right now, all we have is side, side, side to prove these are congruent. What kinds of information am I given in the given? Two of the three sides. So I already have the S and the S. Yes, I just need the third side, which is what? The reflexive side. GJ is congruent to GJ or JG. And that is reflexive. So now I've got all three pairs of sides. I can say triangle. GHJ is congruent to triangle JKG. And that's side, side, side. It's like the world's easiest proof. Questions? All right, second one says WX is congruent to VZ, WY is congruent to VY, and YZ is congruent to YX. So that's all the stuff that's marked. I need to prove that, again, these triangles are congruent. So if I, again, think about side, 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 this side is congruent to this side. So that's one of the S's that's already used. I don't need that I could check off my list, right? These are the other two sides, and they are not yet proven the entire side is congruent. If it had said WZ equals VX, then I can say I have the other side, but I don't yet, right? I have the parts of them, which makes sense that if I add them together, they're congruent. But I haven't stated that yet. So this is just like the one we just talked about in the warm-up. I have to go through that whole process. I have to show that this plus this would equal this plus this. To do that, I have to break them each down into the sum of their parts. So I have to say that Vx equals Vy plus Yx. And I have to say Wz equals Wy plus Yz. And what did we say that is? Segment addition postulate, when the sum of the two parts equal the whole. Then I already said that individually they are equal to each other. I said that Wy equals Vy and that Yx equals Yz, but I have to take them and add them together. So I can take this statement here and add it to that statement there. So Wy plus Yz equals Vy plus Yx. And I added two things that were congruent to either side of the equal sign, which is the addition property of equality. And now because I said that this, which is here, is the same thing as this, and this, which is here, is the same thing as that, I can, in the place of the two parts, rewrite it as the whole. So Wz equals Vx, and that's substitution. Now I've got my second pair of sides. I still need one more. How do I get that one? Reflexive, that's the easy one, right? So 5, that other third side is shared by both. So WV is congruent to WV reflexive. And now I've got all three side lengths, so I can say triangle VWX is congruent to triangle WVZ. And my reason is side, side, side. Questions on that one? So a little bit more complicated, but still you guys figure out if you're doing side, 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 it's three sides. Okay, 26 says AE is equal to CE. That one's given to you. And then it says AB is congruent to CD. That one's given to you. And then E is the midpoint of BD. So again, we've got side, side, side. I already have two pairs of sides. How do I find that third pair of sides? Good. Definition of a midpoint, right? Tells you that these are cut into two equal parts. So BE would equal ED. Definition of a midpoint. And then I've got all three side lengths. So triangle EAB is congruent to triangle ECD. C, D. Side, side, side. Questions on that one? Again, back to the easy side spectrum. All right, this one, FM is congruent to FN, which is this one, FM, little guy, to FN. DM is congruent to NH. EF is congruent to FG. And DE is congruent to GH. So if I'm trying to prove that this triangle is congruent to that triangle, right now all I've got is one of the side pairs, right? One completed pair. I basically have two that I have to add two segments together. So I have to do this segment addition postulate thing twice. Once for GM and EN, and then once for DN and MH. So I'm going to start with my reflexive side, get it out of the way. I mean, sorry, not my reflexive side. I'm going to start with the segment addition postulate. So MG equals MF plus FG. EN equals EF plus FN. DN equals DM plus MN. And HM equals MN plus NH. All of that is the segment addition postulate. I basically just broke those two sides in each triangle down into their parts. Now I have to do the addition postulate to say that this plus this equals this plus this. Well, I already said the individual parts are congruent, so I can say that EF plus FN equals GF plus FM. And I want to repeat that for this plus this equals this plus this. DM plus MN equals MN plus NH. And that's the addition property of equality. I added congruent parts to both sides of my equation. So now, because I said that this is equal to this, I can take the EF and FN, which is here, and set it equal to the MF and FG. So EN equals MG. Oh, that's so sloppy. And then because this equals this, I can say that what this equals is equal to what that equals, which is DN equals HM. And that's substitution. Now I've got my other two pairs of sides. So I can say triangle DEN is congruent to triangle HGM. Connor. Because you're taking, so like here, right? Like if I'll clear all this off. Let's say these had actual values on the sides, right? Let's say that this was 5, 5. Let's say that this was 6, 6. This is 8, 8. And let's say this is 2, 2. And let's say that's 3. Let's say they're all values, okay? So what you should know is that if I took this 8 and I added 2 to it, I'm going to keep it also congruent as if I took 8 and added 2 to it, right? You're taking two congruent parts and you're adding the same thing to both sides of the equal sign. The only reason I can add to both sides of the equal sign is because these little congruency marks are here. Because I'm basically saying I'm taking 2 and I'm adding it to both sides of the equal sign, right? But because this whole part is part of the big triangle I'm trying to prove congruent, I have to use it as a sum of its two congruent parts. So that's the angle addition postulate part. I mean, segment addition postulate part. I have to say that this whole side is the sum of its individual parts. And then the only reason I can add them onto both sides is because these are marked as congruent. If those weren't marked as congruent, I couldn't do it. And you have to do it for that, and then you also have to do it for this. You're basically saying these started out congruent, right? And then I took the same length and added it to both sides of my equal sign. Does that make sense? You're adding something that's the same to both sides. So the 4 congruency marks was already congruent to the 4 congruency marks. And then I took something that's the same and I added it to both sides, which in the first case was the FM and the FN. So if you're given a side length as a sum of 2 parts and those 2 parts are congruent, you have to do both steps. Say that the segment addition postulate says that the big one is the sum of the 2 smaller parts, and then you have to do the addition postulate. The addition property, which adds them to both sides.
So the addition probably that gets the segment addition. What you got from the segment addition postulate and make them equal each other.
No, so this is because EF was equal to GF, right? In my initial drawing, those 2 are equal. Those are my 4 tick marks, right? And then I took and I added FN and FM, which are my single tick marks, to both sides. Because those are congruent, I can do that. I can say that if those are the same lengths, I can add them to both sides of that equal sign.
You can also do FM too, right?
FM. Say again.
You can do like instead of FN, it will work for FM because they're congruent to each other.
So that would be substitution. I can't do that because yes, you can do that, but I actually want to get that this whole side equals this whole side. So what that step doesn't really accomplish that. Does that make sense?
Yeah.
Okay. And then I did the same thing for the bottom side. I took something that was the 2 tick mark, which is the FM or the DM and the N and the NH, those 2, and I added to it, this time it's the same side, which is MN. I added MN to both sides to show that those would be congruent. If I took that same part and added it to both sides.
Why did you have to do FN for the top one instead of FM?
Because I need FN instead of FM, you saying?
Yeah.
Because that segment is EF plus FN.
And the same for FND, you can just do that to them.
FND. Say that again?
Like if you do EN, you have to do FN because that's what's like paired. That's what's
Correct. That's the part that completes that side. Right? I need to show that this side equals this side. So I have to add the 2 segments that make it that side. And then I had to add the 2 segments that make it this side. I have to show that big sides are equal by showing that the sum of the smaller parts of each side are equal. And actually, because we added MN to both sides before I got to this step, we should have done MN is congruent to MN, and that's reflexive. Because we added the same thing to both sides. It should have been there. The good news is you're going to get lots more proof practice before your test because the next 3 steps are all continuing with proving triangles are congruent. Okay, so 4, 5, now we're learning 2 more acronyms, 2 more shortcuts. One is SAS and one is hypotenuse leg. So after today, you'll have side, 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 side angle side, hypotenuse leg, and then tomorrow we'll get 4 more.
When's the test? Next week?
Next Thursday, like actually Halloween, which means you'll have no homework Halloween, which is a good thing. Yeah. All right, so included sides and angles, okay? So if I look at a triangle and I'm trying to figure out what's the included side between 2 angles, it's the side that connects those 2 angles. So if it says AB would be the included side between A and B, because if A and B are here, the line that connects them is AB. So I would say that AB is the included side between angle A and angle B. It's the one that connects them. So if I had asked you for the included side between angle A and angle C, you would tell me it's what? The included side between angle A and angle C would be? AC. If I said between C and B, it's CB. Okay? It's literally made up of the letters that connect it. The included angle is the angle where the 2 given sides meet. So if I say what's the included angle between AC and CB, then I'm looking for where AC and CB meet, which is at angle C. If I ask you for the included angle of AC and AB, what would you tell me? Angle A. where the two sides meet. Okay? If you're given letters, it's where the overlap is, but you're not always given letters. So you just want to be able to identify it. And this is why you need to know what an included side is. So the SAS postulate is two sides and the included angle. So I don't need all three sides anymore, but I do need two sides, and then I need the angle where those two sides meet in one triangle to be congruent to the two sides and where those sides meet in a second triangle. So if you were given this, AC is congruent to DF and CB is congruent to FE. If I wanted to prove these triangles were congruent based on side angle side, what other piece of information would I have to know? Camilla. Angle C would have to be congruent to angle F. So the angle where the two sides meet, okay? And then I could say triangle ABC is congruent to triangle DEF, and the order of the letters is important. And my reason would be side, angle, side. Bless you. Bless you. So side, angle, side, two sides, and the angle where they meet.
We don't need postulate then?
We're going to get into similarity, and similarity you need that, but for congruence you can just give me the three letters. Parts of a right triangle. So hopefully you remember this, that the two legs are where the two sides that meet at the right angle. And then the hypotenuse is the side opposite the right angle. It's also the longest side of the triangle. Come sit here. Okay, and then the reason you need to know that is the next acronym is HL. Notice it's only two letters, okay, where all the other ones were three. That's because before you even look at the triangle to see if it's HL, it has to be a right triangle. So you already know it's a right triangle. That's the first piece of information. Otherwise, it doesn't have a hypotenuse. If you have two right triangles and the hypotenuse of each are marked as congruent, and then one leg of each is marked as congruent, then those triangles are congruent, and your reason is hypotenuse leg, or HL. All right, they're obviously not trying to scale. But if I started with this, the first thing you would need to know is that these are right triangles. As soon as you see the right triangle, you want to check for hypotenuse leg. So for that to be the case, then if I had AC marked as congruent to EF, what other piece of information would I have to have in order for these to be congruent?
CB is congruent to DE.
Not CB. That would make it side angle side, right? But what's going to make a hypotenuse leg? AB and DF. So it has to be the hypotenuse. And then I can say triangle ABC would be congruent. Now I went hypotenuse to the side that wasn't marked, so I have to do the same thing on the other side. F, D, E. And my reasoning is HL for hypotenuse leg. Now, it could be either pair of legs. So instead of having AC marked as congruent, I could have had BC and DE marked as congruent. As long as one pair of legs and the hypotenuse are marked, it could be either one. Check. Questions on that? Okay, so okay, so these just say state which congruence method or methods can be used to prove the triangles are congruent if none state NC. So you don't have to give me like a full drawn out proof. You just have to state yes or no. Are they congruent? And if they are, which of the acronyms can you use? Now you've got 3, right? Because if we take into consideration what we learned yesterday, we've got side, side, side. We've got side, angle, side. And you've got hypotenuse leg. So you almost have like a bank to choose from. All right, so if you look at A, are those 2 triangles congruent? Why? So the thing that's not marked is this reflexive side, yes? So I do have 2 pairs of sides, yes? Do I have the angle where they meet?
No.
These are not congruent. It has to be the angle where the congruent sides meet. Don't let it trick you, okay? Oh, you're just raising your hand. Does that make sense? Okay. How about B?
No, that's B.
What piece of information do you have?
The right angle.
They're a right angle. If one's a right angle, those are a linear pair. This one has to be a right angle, right? So this already is a right triangle. It doesn't mean every right triangle is congruent to another one because of hypotenuse leg. But as soon as you see the right triangle, you want to check hypotenuse leg first. So are the hypotenuses marked?
Yeah.
Yes. Do you have a side that's a leg that would be congruent? Yes, you have this reflexive side. So this is hypotenuse leg. Sometimes you get a right triangle and it's side, angle, side. Sometimes you get a right triangle and it's side, side, side. But the ones people tend to forget the most are the hypotenuse legs. So you want to check if it's a right triangle, check that first, okay? All right, C, down here. What information, you have 1 pair of sides, right? 1 pair of angles. What information is there that it's not marked already that you know? There's vertical angles, so I have this. Well, I can do 1 arc, actually 2. Is there enough information? Actually, this would be, I could do 3 because one's 1 and one's 1. Is that enough information to prove triangles are congruent? Nope. 2 angles that don't even match, right? This one doesn't match this one. I got 1 side and then another pair of angles that match. But so far, all we have is side, angle, side, hypotenuse leg, and side, side, side. So if I had 2 pairs of sides marked as congruent and the angle where they meet, yes. But the way that it is, no. How about D? What is this? Side, angle, side. So you've got the 2 sides on the outside, the reflexive side down the middle, and then the angle where they meet. And E?
No.
I know all 3 pairs of angles, yes? Is there something called angle, angle, angle?
B.
Nope. Never will be, because you could have 2 completely congruent, 2 teeny tiny equilateral triangles or 2 big equilateral triangles. Okay, they're similar, but they're not congruent. So this is not congruent. There's no such thing as angle, angle, angle. Never will be.
So even if you have all the angles, you would still need all the sides.
Correct. Or you'd need like this side and this side. That would have been side, angle, side. Or hypotenuse leg. Questions so far? Okay, so you will get questions like that, or just like 1 steps, yes or no, and then why, where you're giving a postulate. And obviously, you're going to get things that are a little bit more complicated. So this says, is there enough information to prove the triangles are congruent? If there is, state the postulate. So the first thing is, my advice is highlight the ones they're actually talking about because you've got a lot going on here. So triangle ABE would be here. And then triangle CBD would be there. So what piece of information is, what pieces of information are blatantly stated on this? AB is congruent to BC, so I know that those, I have 1S, right? I've got one pair of sides that are congruent. What other piece of information is blatantly stated? BE is congruent to BE. Now I got 2 sides, yes, I know nothing about that bottom side. There's no measure here or here. If there was, then I'd get side, side, side because they both have that shared part I could add on. Which means I'm going to look at those angles. So if it tells you that this is congruent to this, but this whole angle has to be congruent to this whole angle, can I get there?
Yeah.
How? So the angle addition postulate would tell you that these two are the sum of the interior ones and that these two are the sum of those interior ones, right? And they both share the reflexive angle, which let's say this is angle 1. That's angle 1 is shared by both, yes? So I could add angle 1 onto both of the ones that are already congruent and I would get that they're congruent, which means this is a yes. And the reason would be side angle side. So sometimes you know it just looking at it, and sometimes you got to do a little bit of work to get there. Questions on that one? Okay. Is there enough information to prove the triangles are congruent? If there is, state the postulate or theorem. So now we're saying F, G, H, and H, J, K. What information do you have? Hypotenuse, leg. Now you got to pay attention to the order of the letters, right? Does FG, which is this side, match HG, which is this side? Yep, that's the one that's not marked, right? Does GH match JK? GH matches JK. Those are the single marks. Yep, so this is yes. And it would be hypotenuse leg. Questions on that one? Okay, last one. State a third congruence you would need to prove the triangles are congruent by side angle side. So what I am given is that ST is congruent to YZ and RS is congruent to XY. If I want to prove it by side angle side, what other piece of information would I need? Say again? No, side angle side. That would be side, 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 right? Angle S and angle Y. It's got to be where the two sides meet. Everybody good? Yes? Okay. So when you do, I'm going to publish it now. When you do tonight's homework, keep in mind that you have side, side, side from yesterday. You're going to be, God bless you. You're going to be adding that to your list of how you know. So you've got side, side, side. Oops, that you can't see. Side, 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 side angle side, and hypotenuse leg. And then again, tomorrow's section, we're going to add some more. Okay, but for right now, that's in your bank.